Hello, I'm Andrew McPherson.
And I'm Landon Morrison.
Our Chi paper this year grew out of a cross-disciplinary conversation wrestling with the concept of entanglement in recent HCI literature. The paper grew to be quite long, so this video is intended partly as a guide to reading the paper and partly as a summary of a few examples. As we go along, we'll put up a few references as QR codes. For convenience and for screen reader support, a copy of this video with references in the text description can be found at youtube.com/augmentedinstrumentslab.
This is a theory paper about entanglement HCI, or relatedly post-human or more than human HCI. Building on the work of Christopher Frauenberger, we take this term to mean a bundle of theories which suggest that the very identity of people and things is bound up in their relationships with one another. This includes philosophies like agential realism, object-oriented ontology, actor network theory, and post-phenomenology. Now, there are, of course, important differences between these, which we won't have time to fully flesh out here, but which we do address in section 2 of our paper. For now, an important point is that entanglement challenges convenient dualisms between nature and culture, mind and body, human intentionality, and inert materials. This means that entanglement moves away from placing the human at the center of every story, calling into question narratives of great inventors working in isolation to solve complex social and ecological problems. We're enthusiastic about the prospects of entanglement HCI, but at the same time, we'd like to dig further into how these theories might cause HCI researchers to do things differently. Thus, we ask, so what? Why should we care? And what's the reward for wading through this philosophical thicket?
Now, the two of us approach this question from different disciplinary perspectives, so our paper is written in the form of a dialogue. I'm coming from a background as a composer, an electronic engineer, and HCI researcher. My interest in entanglement is especially around turning theory into practice. So when I sit down at the lab bench to build some circuits or write some code, I want to know what I should be doing differently because of this theoretical framing.
Meanwhile, I'm coming from the worlds of music and media study, so my interests lie primarily in turning practice into theory. This means that we're often running in opposite directions.
Given this, we model our dialogue on the idea of diffraction, which comes from the work of Donna Haraway and Karen Barad, and denotes a way of generating insights by reading divergent perspectives through one another without attempting to reconcile them, instead attending to the differences and interference patterns that emerge. Barad exemplifies this approach in their article Diffracting Diffraction, and we find similar arguments in the HCI literature, for example the paper by Pedro Sanchez et al., Diffraction in Action. There are more examples in section 2.2 of our paper.
Now, structurally, our paper has 5 sections, including an introduction, lit review, case studies, provocations, and a conclusion. These need not be read in order from start to finish. Rather, we encourage readers to skip around according to their own interest. So for those that are theoretically minded, you might start with section 2, which offers a thorough lit review on the origins of entanglement, how the term is propagated across different disciplines, and some of the frictions that result. Here we take up the question of whether subscribing to an entanglement worldview requires rejecting hard-won insights from previous waves of HCI, such as those pertaining to reflexivity or representation, which come under heavy critique from the likes of Haraway and Barad. Another path is to jump to section 3, where we present musical case studies. We're musicians ourselves, and a central premise of the paper is that studies of musical interaction have a lot to contribute to the HCI conversation around entanglement. Finally, you might choose to skip over section 3 and go straight from section 2 to the provocations presented in section 4. This path will let you focus on theory without getting too bogged down in music-specific examples.
Now let's step back for a moment to this question of so what? What do high-level entanglement theories have to say about specific design cases? So now we're going to drop into the middle of section 3 of our paper and look at a couple of musical examples. Specifically, the paper focuses on 2 very familiar instrumental paradigms, namely keyboards and step sequencers. We're not only looking at specific material objects, but also the very idea of them. So rather than this piano, or pianos as a class of instruments, we look at the broader idea of what Emily Dolan calls keyboardness. We also dig into what Ryan Diduck calls claviocentrism, quote, the centuries in the making cultural logic that places the piano keyboard in the middle of the musical instrument ecosystem. Let's ground this in an HCI-related example. Here's the Makey Makey. It's a programmable board that lets anyone turn everyday objects into sensors and sound generators. People encountering this board often make rudimentary keyboards out of their objects, the so-called banana piano. Of all possible musical approaches, why is this so many people's first impulse? Entanglement theory can help us understand the phenomenon by examining the tight bonds between the keyboard as a material object and a discourse of control and virtuosity. Then in section 3.2, I present a self-critical example from my own work. I mentioned earlier that I want to know what should be different about my design practice because of entanglement theory. That question is still open, but I have found entanglement useful to understand where my previous work might have gone off track. This is TouchKeys. It's a capacitive touch sensor technology that affixes to the surface of the electronic keyboard and measures the position of the performer's fingers on the key surfaces. From this data, one can derive control signals using the MIDI protocol for manipulating the sound of the instrument. This enables techniques like vibratos and pitch bends. I've made quite a lot of these instruments, which are being used by musicians around the world. But for me as a musician, something has never quite clicked. And I've identified two problems here. One is around the MIDI protocol and the way that it takes specific and situated ideas from the electronic keyboards of the 1980s and gives them an inflated status as universal building blocks of music. But there's also a more general problem, which I'm calling design by analysis. It involves starting with familiar descriptive words about music, giving those words numbers, and then treating the result as a generative space for music itself. For example, let's say that we start by thinking about pitch, volume, and some aspects of timbre. We might end up with a numerical dimension space, and we could propose to analyze existing music as a navigation of that dimension space. But then the designer tends to follow it up by taking sensors and code, building a new dimension space that purports to capture the player's interaction with their instrument. Music making thus proceeds by connecting one space to another in a process that is known as mapping. That's more or less how TouchKeys was formulated. But in this paper, I examine how this process has a way of putting symbols and representations ahead of the experience of music making, and how this supposed openness of being able to map anything to anything else actually hides the strong ideology built into the system. I suggest that it might be better to think about instruments using Barad's notion of the apparatus. Rather than the instrument offering the player a neutral and detached notion of control over some universal building blocks of music, something that I would argue is neither possible nor desirable, I suggest that the instrument and the musical phenomena it elicits are fundamentally entangled with one another, such that the act of even taking a numerical measurement already carries responsibilities, bringing some possibilities into existence while foreclosing others.
We also consider the case of step sequencers, which in some sense do for musical time what keyboards do for musical pitch. That is, they convert continuous temporal phenomena into a series of discrete steps that can then be organized into rhythms and metrical patterns. While step sequencers come in many shapes and sizes, one of the most recognizable is that of step entry drum machines like the Roland TR-808. The interface lays out a series of 16 buttons, each of which corresponds with a unit of time in a musical measure, most commonly 16th notes in a 4/4 time signature. It thus encodes a hierarchical conception of musical time that is based on metronomically uniform beats. The result is crisp, cookie-cutter rhythms that are characteristic in many 80s pop songs and which continue to be prevalent in many styles today. The model also extends to live performance through the use of quantization, which snaps real-time rhythms to an underlying metric grid in a bid to correct small micro-timing errors, much in the same way that auto-tune is used for pitch correction. In the paper, we framed the mapping of a performer's actions to an underlying representation of musical control by referencing critical media studies authors like Wendy Chun and Alexander Galloway. For them, interfaces act as an allegory or an analog of ideological control by simulating relationships between users in a virtual world. As Chun puts it, any kind of mapping is also a being mapped because it, quote, concretizes our relation to invisible sources and substructures. In the case of drum machines, we might think of how the contemporary musician or user is brought into contact with a hierarchical representation of meter that stretches all the way back to the 18th century with theoretical treatises in the Western classical tradition. And yet, as Galloway notes, interfaces can also be interrogated and subjected to close historical analysis, and critical approaches to interface design and use can also be adopted as a mode of ideological critique by drawing attention to the effects of mediations that may otherwise be concealed. There is, in this sense, a double valence to interfaces that tempers what might otherwise lapse into a kind of technological determinism. So for example, in the music of artists like Jay Dilla, one hears vivid examples of rhythm quantization being wielded against itself, producing warped, off-grid beats that cut against normative applications of the technique. Now we step back from our musical case studies and turn our attention to section 4 of the paper, which presents provocations for HCI. Again, let's go back to the question of so what? We argue here there's a risk that the word entanglement becomes stripped of all meaning. In a vernacular sense, it could suggest this vague idea that everything is connected to everything else in a kind of infinite recursion. But this is a dead end, not only because it doesn't really yield much insight for either design or theory, but because, as scholars from critical race and decolonial studies have argued, it risks erasing cultural differences that do indeed matter, flattening everything into a homogeneous whole that is void of historical specificity. As an example, take ecological precarity, which has been a rallying cry for post-humanist HCI. But it's hard to see how a generic interpretation of entanglement could account for the fact that the effects of ecological disaster are not evenly distributed. Thus, for HCI, our provocation is to take account of the philosophical origins and baggage of these theories, attending to the ways some groups have been left out of their purview, and finding ways to re-inject a concern with cultural politics into what otherwise risk being instrumentalized as a kind of panacea for generating new design methods.
With all of this in mind, what then should we do as designers? And how can we avoid this overwhelming sense of paralysis that could stem from the idea that entanglement becomes all-encompassing? Fundamentally, we see entanglement as being about accountability. Entanglement theories tell us that the boundaries between humans, technologies, and the material world are not fixed or preordained, but that doesn't mean that boundaries never exist. Rather, we participate in enacting those boundaries through the decisions that we make as designers and researchers. Every decision brings certain possibilities into existence while foreclosing others, in what Barad calls an agential cut.
In closing section 4 of the paper, we reference the absurdist plot of a recent movie, Everything Everywhere All at Once, where the main character is stricken by a sense of nihilism that threatens to suck them into the black hole of an everything bagel. We frame this as an instance of what Haraway describes as the God trick of, quote, seeing everything from nowhere, which she cautions can lead to the dual traps of absolute objectivity or total relativism. As an alternative, we invert the title to argue that we should be seeking more localized forms of knowledge, searching for something somewhere in a gradual fashion. This is in line with Haraway's prescription of embracing what she calls, quote, partial locatable critical knowledges.
Music exemplifies some of these challenges while offering ideas for ways forward. Contrary to the old cliché, music is not a universal language. It may be a fundamental part of being human, but there is no universal or generic music. only countless specific practices situated in time, place, and community. Designers therefore can't rely on fixed and decontextualized words and symbols to build their technical systems. And conversely, theorists can never fully nail down musical practice, as it is always in a dynamic process of rejuvenation that should cause us to constantly reassess our theoretical commitments. The way that musicians grapple with this ever-shifting landscape offers resources for other areas of HCI. To conclude, entanglement design is really entangled design. It is not something that can be imposed from a distance by the designer, but rather it calls for a critical awareness of one's own positionality within always entangled relations. The trick, therefore, is not to disentangle oneself, but to reconfigure those relations toward better futures whenever and wherever possible.